Welcome again. I'm continuing the scripts, 126 out of the 1001 scripts. As you know, I've been working on, so I may as well indicate that. I'll be sharing files. I'm going deep into ModeLabs again and again in these series, and I find just focusing on this is essential. I'm going to focus on the series Developing Python Components to start, because I think that's really the place to begin, even though there is an introductory series on Python through ModeLabs. So let's just jump in there and see what they do. They basically go in, actually this one I pulled out of another script. You go in, you set up your Python out of maths, you set up your Python node. I've got a Boolean running to x, which is all that's important in here, and I've got an if statement. If x, then put to output a, hello world, else put nothing to say. So if I put it false, nothing to say, hello world. Nice and easy. ModeLabs starts with this series. Double click on it, you'll see what's there. Basically, it's importing Rhino syntax as RS. You don't need any of this stuff to start. If you want to eliminate that, that's fine. And they progressively get a little more complex. So printing hello Michael Wickerson, boom, that's in there. And then I also want to send to A, hello Michael, print A. A nice little example of what you can do here. So A, you're going to get hello Michael, and then you're going to see your output of everything that's coming out over here. You do not need the Y, and I believe the X in this is set to a string. And I probably went in and typed the type right here. So if I right click and hit type hint, you're going to see that I indicated that was, actually it's a gh-doc object, so that's fine. I can just leave it as the script syntax. I didn't have to say it was a string. You will have to specify that when you go into here. Next one, as I jump in here, I'll pull this up and I'll do preview on. You can see I have a basic point that's being generated in my Rhino window that has a script that I can move it around. It's not very high tech, but that's exactly what's being outputted. Once again, you do not need all this script to begin with, comment lines and things like that. You're going to import Rhino script syntax as RS, and then my point is set to the Rhino script syntax of add point at x00, and A is going to be your point, so it will output that. Easy enough. I'm going to actually save that, and there we go. You can see your point moving around. Slowly and slowly, this gets more and more complex. Let's take these objects and put the preview off and go into the next script. The next script is going to write a series of lines. So how is that possible? So when we go into here, we basically are writing a script that says, once again, and there's some pseudocode, and I started to use that so I knew what I was doing, define a list of multiple values. You have to define A as a list now, because you now have not a single line coming out of here. You have a double line coming out indicating a list, not a dash line for a data tree, but right now it will be a list. And because you want to record each one as you go, you're creating a loop, step through I, which is for I in range 0 to X, which will be your digit coming in. You are going to create my point equaling the Rhino script of adding a point at I00. And then you will have to append A in the sense of my point, otherwise you'll just keep getting a single point as you go along. So as you draw this, you'll see the points that come in before it and all the way up to whatever you have, 10 points. That should be fairly straightforward. Things start to get complex fairly quickly as we go through this. Let's go into the next script and turn this one on. Actually, I think I'll just highlight it. You have a grid of points now. So how is that possible? And how can I play off of that? Well, that's interesting. It's a list. So I'm able to, and it still comes as a single list, not as a tree. But what does the script look like on that one? Importing Rhino script syntax is RS. You create a list of A, so you have to put it in the blank brackets. And then you're going to run through I in the range of x0 num in the x direction, and then you're going to have to nest a loop in there of j as range in 0 to the number in the y direction. You will then have to indent again to nest within there, the my point being the Rhino script of adding a point at ij, this time 0 instead of I00 and j 0j0, but now you then append it once again as A being append to my point, and that will be your output. You do not have to do the output for this one because that's actually just being created. You don't have to say A is equal to my point. You've got it actually calculated here as this loop. So there you go. You've got the ability to play off of that. And once again, it is still a list. There's no dash lines here, and we'll go a little deeper into it. Let's jump here and take this one to preview on. And what's going to complex here is we're going to actually start to take a look at making a surface. That is done in Rhino and internalized here to start. And what's happening here is with that surface, I am able to put points on that surface and control how many points by dividing that surface and how many times I want to make it. So what is the command for dividing a surface? And here it is. Import Rhino script syntax as RS. Define the output list. A is a list now, so you must define it. It's easy to set your types, and I'm kind of going over that. All these types have been set. this type has been set to a surface, the next one's set to an integer, and the next one's set to an integer. So you can set them as they're coming in, but even as they're going out, they have to know what they are. So you're setting it to list. A little bit of pseudoscript, and basically for I in range 0 to num u, and the +1 wasn't there to start, but for j in range num v in the v direction, u and v directions, you're going to basically evaluate surface, which tells you to do surface, and then to get a number between 0 and 1, you're going to have to divide I by num u and j by num v, and then you append it the exact same way. You don't have to put an a equals anything in the end is my point. And there you go. And you'll find when you do it without the +1, you're not going all the way to the extent of your surface. So it would stop short, and there wouldn't be points here, and there wouldn't be points on that edge. So in doing the +1, because of the range, you have to add something to it as you divide it. The numbers on there are pretty interesting to take a look at, but once again, it is just a list that runs from 0 all the way up to what's the final number? 40-something, 49. Just keep plugging through those scripts. They're there for you to do. You can write them along. You can download their files if you did their webinar. I don't know if that's... The point list isn't going to make any sense for this one because now we're going into polylines. So we're not dealing with points. We're dealing with polylines as a cell, not as a point. And you'll see the changing of these names from A over to things like cells. So once again, I can go in here and I can actually create these cells instead of just dividing to points. And in doing so, let's take a look at our script. And they've reparameterized the surface. That's one thing you don't want to miss. But importing Rhino script syntax is RS. We're about halfway done. You're going to set up a dictionary as a set, which is, well, dictionary curly brackets is what goes in here. Define a dictionary that stores the points. And then cells will end up becoming that list. So for the I in range, staying with the exact same formula, you're going to do your my points. The only change is you've got to change that, what you had, to the dictionary reference of A at that key of I, J, and those will be your points. And then the final statement in there will go on to a for I in range 0 num u and j of 0 num v. You've got to put down my quad and walk it through almost like the same way you do in relative item or relative items node in Grasshopper. If that's not making sense, take a look at data trees. And he does it all in one line, stepping over, stepping up, stepping back over, backing up, and then back to the original point. And then he creates a cell appended to those quads. Those points are added 1, 2, 3, 4, and back to the center again. It's kind of like closing a polyline in Grasshopper node. And there we go. You're able to get in there, test that, run that, and there you go. You've got total control of producing quads. They continue right along. So let's take that one and just put preview off. Let's go into the next one and preview on. And what we have here is they've added a cell type because we may want to try in our cell. We may just want a quad. So they added a formula for actually adding in a try. Let's go ahead and see how they did that. Double click, and what's happened here is it's getting more and more complex as you go, staying with the original script. You still have a dictionary, you still have a list, you follow through with the key reference for the points, and as you go down, you're going to have to find out if the cell type is 0 or if it's not 0. And of course, this is an if-else statement, which will take it to quads and take it to tries, and the tries being divided into A and B, and the quads being set as just one single type. And you'll see in writing that the only change is they have to do a walking pattern of over, up, and then right back to the original, and over and up one and right back to the original. So you can build these, so you can walk through and build these triangles. It's actually just like a walker or like a turtle tool in Python. It's not that hard to figure out. Cells have to be appended to their tries, and you've made your quads and your trides, and your scripts runs beautifully. That can go back and forth between the two of them. Rhino Common is then announced, and this is a while ago, 8 years ago. I don't know if Rhino Common still is a necessity, and this is where things get more and more complicated as you get through here. And I end with this script. Not just ending with that script, but as I go into the last Python script, they actually end up building a node that I can bring in up here. And if I extend my Grasshopper, this is very nice. I've ended up adding a Modelabs creating user object. So I can grab that user object and bring it in, and I can always take a gridded surface and come up with these really cool kind of walking paths of any surface I type in. Because I like the form, once you like your script, you're going to want to find out how to do it more and more again and again. And what they've also done is they point listed it, and you'll see at this point in the script, we are not dealing with a double line of a list coming out. They've actually begun putting things over onto their own data trees. So with here, you've got 9 branches, 22 items. You have a tree looking like this, as opposed to going into here and taking your param viewer and looking at the list and realizing and looking at a large list, it's just going to look like a tree item like that. So now you've actually got lists of lists, and that's the whole point of getting into this script. So I'm going to go into the try script. It doesn't work on the quad, but it does work on the try. And as we go into the list, you'll see that there's a lot of particularities of what has to be done. Importing the Rhino syntax, and then boom, he gets into a lot more complexity with bringing in CLR, common language runtime, importing from that, adding reference to Grasshopper, then going into the Grasshopper kernel and accessing a GH path. So all of it is in this upgrade, and that's something I haven't wrapped my head around. I just have to copy, cut, and paste it. And then there's a few changes from the Rhino's script syntax script over to Rhino Common methods, and there you'll see that it has to translate a little bit in what's being interpreted, and in doing so, there and there and there in those sections at the beginning of what my point would be, you then have to go in and do a little bit of moving around in Rhino Common methods for walking through the tries A and B, and in doing so, you then have to change what you wanted from the dictionary of A to the cells. You're going to have to change a little bit of how you write out your cells as my tree in the end. So that one I literally just have to walk through to understand, but it builds a really nice node that does not pull out a list of data. It actually creates a node that will create lists of quads or tries on top of any surface I want to use, and you've written that into a very nice Python script. So there you go, 11 and a half, 12 minutes to summarize, 2.5 hours of video for ModeLabs. You're definitely going to have to go on still and definitely type those in, and I will put a link in here for you. Just let me get out of here for a second, go back into ModeLabs and say that is the, what was that one called? That's the developing Python scripts, and I'll just hit pause here for a second. It's developing Python components, and he actually shows in the end how to make that a component. Let's just grab that little... let's grab that link, and that'll be in there for you in my files if you want to go over and watch the scripts in lengthy terms. Otherwise, you've got them there written down, and I'd say take full advantage of it. Learn how to start using Python. I will go on in the next series to a, instead of this one, this series, I'm going to actually go back. Let me give you the name of it. It is the Intro to Python Script series, and it is a pretty cool one as well. I will drag it over here and you'll have a look at it. It's this one right here. So the ModeLabs free webinar in 2012. This will be the Python scripting 01 introduction, and run through these nodes right here. Sorry, these scripts. And we'll try and do that in 15 minutes as well, even though these seminars are a little long. So they're all supplemental information. I hope you enjoy it. Thanks very much for watching.